Hey everyone, and welcome to this episode of Co-Creating with AI. Together with us today, we have Malcolm Sparks, founder and CTO of Juxt, which is the database we use at Multiply. Malcolm, welcome, and how are you today?
Hello, I'm fine. Great to be here.
And also with me, as always, is Rasmus. Are you good today, Rasmus?
Yeah, I'm good, thanks. I'm in the city today, so not at my house, which is always a nice change to mix it up a bit. And also, by the way, I mean easy slip of the tongue, but the database that Juxt and Malcolm has built is called XTDB, which is the
Oh,
best of a relational and a graph
yeah.
database, which we use in Multiply to
So what did I
power
say?
our use case. You said Juxt is the database, but
Oh, okay.
it's fine.
That's the company, and of course, XTDB is the database. Cool. And so, Malcolm, for our listeners that are not familiar with you, do you want to give a short introduction to yourself?
Yeah, I give a quick personal introduction. I fell in love with computers in about 1981 with a ZX81 and learned BASIC and all that stuff. So I became a developer fairly early on, did a CS degree, and kind of started my career, I suppose, properly in '94. And then, yeah, it was kind of like worked in databases, Oracle and forms development, and then discovered Java on the kind of almost on the day that it came out, and kind of was completely involved, fell in love with that and object orientation and so on. That took me all the way up until kind of 2009, 2010, and then I kind of was working in a bank and discovered a language called Clojure, which is a derivative of Lisp, of that family of languages. And so again, I kind of converted to Clojure, used it for a small project, and was completely sold on its unique value propositions, and so have been working with Clojure since that time. In 2012, 2013, kind of left the bank and started a company with John Pither called Juxt. So we've just finished we just had our 10-year party last month. So we're 10 years old this year.
Amazing.
Congratulations.
Congratulations. And how big is this company now?
We're about, I think we're about 70 full-time employees and about the same number of kind of contractors.
Yeah.
And we do a lot of work in investment banks, fintechs, but globally around the world, different industries.
Is it fair to say that database companies are a special breed? Do you think is there
Well,
something that makes that a category of culturally as well as?
yeah, yeah. I think I mean we're quite a different company in that we've built building products through just having one, at least one leg in consulting and working with customers and problems and seeing problems every day. So, there are kind of types of products that come out of real world experience rather than products that are created with ivory tower thinking. And so we're very much a kind of hands dirty, getting things done, finding real problems, and products are really for us a reflection of our experience, which I mean, hopefully is a good um, inception process for any product that you start with deep problems that people have, rather than inventing the problems. You kind of experience them. So very much real world conception.
Awesome. Thank you. So Rasmus, I know you were excited about inviting Malcolm for deeply philosophical reasons. Do you want to frame this episode and conversation for us?
Sure. I mean, this just started because obviously we're using XTDB, and Malcolm and I had the first chat a week or so ago, and then we got into all these fun topics of how the internet started and the ideas behind XTDB, and of course Multiply, and what we're using it for, and our ideas behind it. So I think like a nice framing for today, just based on kind of what we found interesting in our first conversation, Malcolm, is kind of the co-created internet. And just to sort of relate that back, I mean, you were obviously there, I wasn't, but I know a little bit about, I guess, the history of the internet. And it began as read write, primarily via terminal before, or like a text interface before, obviously Mosaic and the browsers came and the kind of GUI. Um, so for those who don't know, like at that point, and maybe you can fill this out, Malcolm, so correct me if I'm wrong, please. It was a little bit like every website was a Google Doc that
It was,
had
yeah.
full share permissions. so that if I put up my website, it was a Google Doc that you could go in and edit, which is, of course, a very different kind of thing. And just touching back on co creation, right, which is what we're passionate about, and of course, what this podcast is about. If I can actually, if you create something, you put up your website, and I can actually edit it. Now that is a co-creative process. Whereas what the internet evolved into was, a once again, just like the kind of mass media age before that, it was more broadcast. I put up my website and you read it and look at it, which of course has its benefit. And then you had Web 2.0 with like social media, etc. And you have a lot of platforms that allow, more peoples to be publishers, etc. But there was like something quite fundamental there that is, from my understanding, also like insights or learnings or maybe dreams that are behind like XTDB and of course behind Multiply, which I won't go into anymore now. So maybe you can just comment on that, Malcolm. Like, what was that like, and what do you think got lost there? And also maybe lead that into like XTDB and the like what it is and how it works and why.
Yeah, I can tell the story. I'll tell the story of what it was like when the web came out for me. I mean, it's a very personal story, but you have to go back into, I think I discovered the web around, I think, 95, 96. In those days, that was kind of peak Microsoft Windows. Linux really wasn't, I think it had been, I think Linux came out in around kind of 92, 93, but it was really much a kind of a hacker's thing. And Macs weren't really that popular. So they were just used in design labs. So everyone had Windows. You had these modems that you would connect to. You would have to get a subscription with a internet service provider, and you would have these funny modems, which I'm sure you might remember, just these things screaming these um, the really, really loud noises going over the telephone. And then if somebody picked up your telephone, you kind of lose your internet connection. So it was really unstable. Windows was pretty unstable. I think this was just Windows 3.1, just before Windows 95 came out, that kind of era. And the first time I saw a browser was Netscape Navigator. And Windows 3.1 was a pretty primitive operating system or UI. This thing was just amazing. It even had a logo that was animating of a kind of dinosaur. And it was like an alien piece of technology. And then when you got your modem connected and it would, and you would type a URL into this thing, you would go to a website, which would all be gray and black. And every few days, there would be new websites that would appear. So you would go to sites like Yahoo to find out what was hot, what's new. And it was this explosive growth. So every day, every time you logged in, you came back from work and you logged in. And those days, it was kind of before companies got onto the internet. Now, around 1997, I remember being in a department of people where there was just one internet terminal. You would have a queue and you would go and sit down and you would have your time reading your external email. So very exciting time. And yes, in those days, Netscape Navigator, which was the browser that I think most people used, there was Mosaic and other things, but that had file edit. You could go and edit your page, your offline pages. You could open up a local HTML page and edit it as if, as Rasmus said, it was like a Google Doc. And then you could publish that page, or you'd save it, and I think you would FTP it up into your little space. Most ISPs would give you a little FTP space. You'd FTP it up, and then you are on the internet. And that was remarkable. So you went on, created domain names and all that stuff.
Can I ask you there, like just for my own understanding? So it wasn't like a Google Doc that I put up my website and you can actually edit the HTML of my website, but you can take that HTML and fork it and publish it yourself. Is that more like what it was?
Yes.
That's right. I'm trying to remember,
Okay.
but it just
Okay.
certainly you
Okay.
could open up HTML files on your local disk and you could edit those. I'm not sure that there wasn't. This was a bit before WebDAV, although it's important to mention that early on in HTTP, the intention was this. A lot of HTTP was built on, and there's some extra methods that are called WebDAV, web distributed. What is it? Authoring and versioning, document authoring and versioning, which were you were meant to have that experience of going to Rasmus site, clicking edit, and being able to put documents, and and so there's some extensions to HTTP that have kind of been lost to history. But HTTP was intended to be a read-write protocol. So verbs like put and delete and things that were there for you to put and delete documents.
And the web is pretty much still like that. You can view source on any web page, and it's out in open how it's made. It's just that nowadays, with the big web apps, they're so complicated that it's very difficult to learn from that direction. But early days, I think a big driver for the web was exactly what you're describing with the open source aspect. Like everything was out in the open. Anyone that figured out how to do something cool also had
Yeah.
to show how.
And links were everywhere. You would edit, and today, if you edited a page, you'd have loads of JavaScript, or you wouldn't see the HTML. You'd just see some sort of, you wouldn't see the payload. You just, the SPAs you wouldn't be able to edit. But in those days, you'd edit the raw HTML content, and links would be everywhere. And you discover this new thing, and you go, wow, I've got this. And then you would link to that site. So there was no idea of keeping people on your site. You wanted people to. And we called it surfing the web, because you would just be clicking from place to place and
Yeah.
discovering things. And
Yeah.
so the aspect of discovery, there was no walled gardens or things like Facebook that kept you into one place. There was later on things like AOL. I mean, that was a very alternative internet where they did keep you in, and there was a thing called Microsoft Blackbird, and which became Microsoft Network, where Microsoft tried to create a walled garden for people to stay in the confines. But people broke out of those things, and AOL and Microsoft Blackbird were not popular. They didn't survive. Where the web, the ability to discover things was much more compelling, and that was the free internet. And it didn't really. It survived a few years, and then there came along things like GeoCities, things that made MySpace as well, making publication much easier. Things like Microsoft's, what was their tool that you use to edit a website? Can't remember. Those tools became very popular. So so it became democratized. So not everybody knew HTML, and it was quite scary. So people started to create things for people to publish their own websites.
That's actually interesting. I just remembered, I had forgot about this completely, but I think I used Dreamweaver and something else to create like a website for my like Warcraft clan in like when I was a teenager. I completely forgot about that. I actually love that. And that was really funny because like that was also one of the transitions, right? Where you gradually reduced the engineering ability that you had to have to be a creator. And of course, now we've gone, I don't know, maybe not the full way, but of course, we're taking our steps with Multiply as well to like allow creators, right, to create products. But yeah, so just to lean it back, so we have this backdrop in history, right, and we have these things that survived, so to say, and became the de facto standard that you touched upon. And we had these things that were there but are not there anymore. If you just look back at this from your point of view and then go into XTDB, what is XTDB and how does it work? How is it unique and why? Because I think if I understood you correctly, and I mean, please don't take me on my words here, but like that it had a lot of like the background of that early era has influenced your thinking.
Yeah, I think so. The real thing about XTDB, for me, is its schemaless nature, its free form nature, the ability to put in documents of whatever form. So you can think with the early web, the document can be anything. Yes, it had to start with HTML tag and body, but it was the freedom to just, nothing stopped you from kind of adding the HTML language, very free form. And as new HTML tags came out, you could choose to use them, but the old browsers would still work. A remarkable thing about HTML was that you could change it. They could add new tags, and but the old browsers would still work. They would just ignore the old tags. And oh, I don't understand what marquee means, so I'll just ignore it. And so this flexibility within the web is what allowed it to evolve and thrive. So if you contrast that with typical approaches for databases, they kind of force you very early on to say you have to know upfront exactly what your structure is going to be, and that can never change. And if it does need to change, well, you have all these techniques like full database migrations, where you have to run scripts against your production data and hope and pray that that weekend the data migration works. So data migrations is not really, that's really a workaround for a problem that data evolution and schema and structure evolution in databases is not first class. The other problem is if you evolve structure and schema within databases, you quickly lose knowledge of what the previous schema was. All the data has to be upgraded. So the only schema that you can ever hold on to is the schema of now, today's latest schema. You don't have a memory. And so the memory loss of databases is something that's built in. Memory loss is important in databases when you've got very expensive disks in the 80s, but you update a row and you lose what the previous version of the row was. But so there's two aspects, I suppose, I'm talking about: having a long-term memory of your evolution to be able to learn from that, but also the ability to be quite fluid with and evolve your structure, which is common to the early web and also common to the closure language, which I mentioned, which has this idea that instead of writing up when you write in a language like Java or C#, you very often write classes. So classes are really the the analog to a relational table. You have to know up front, I want this class to keep the name and the address and the date of birth of my customer, and you have to know up front. And if you were to change your mind or evolve your structure, then you have to do a kind of migration of your classes. You have to go and change your classes and change your code. So I feel that I feel that languages that force you to couple your structure with the code itself, these languages that are very strongly typed, um, actually have a disadvantage in that you couple yourself to one version of your structure. And I think code and structure, or code and form as I call it, should be independent, decoupled, and free to evolve independently. So those are the kind of background
Yeah.
ideas behind XTDB. So XTDB is a very much a database of that era, of that mindset, that you should be able to be free to put documents in and then evolve and realize through recognizing patterns later on that say, oh, these 3 or 4 documents really look like the same thing. Just in the same as in the multiply product, you kind of understand all these documents should all belong to a tag, and I need to evolve my tags, and so everything is free form. You're not having to, when you decide on a tag structure in multiply, you have the freedom later on to change your mind and to change it and evolve it. It's not a straitjacket forever that you have to think up front. So it evolves, and everything, it evolves at the same cadence as the human understanding, and that's what we want our tools to do. They need to support our ability to evolve our understanding, our ability to make mistakes, to to refine and to change our mind sometimes.
Can I just cut in there just to define for those that are even less, technically experienced than I am? So there are two terms in there that I think are maybe worth defining, and one of them is schema, and the other one is kind of relational database and relational table. So I'll just give it a try, and then you guys who are actually have an engineering degree will correct me if I'm wrong. So for me, the best way to explain schema is thinking of like an Excel or Airtable spreadsheet. And the schema is the columns. So maybe your first column says, date, and the second one says project. And this is a list of tasks. So every new task you add as a row in that spreadsheet has the same schema because it has the same columns. In the first column, I put date. In the second one, I put the name of the project it belongs to. And that allows me to filter it, etc. Would you guys agree that that's an okay definition of a schema?
It's a great definition of a schema.
Yeah, or example maybe.
Yeah.
And then the second one, relation. Sorry, go on.
Oh, like I would just, yeah, I think it's a good example because I'd like to then explain what, just imagine for a second if you had a spreadsheet and you had to only write the columns first. You weren't allowed to write any rows in the data. You'd have to come up, the row one, you have to put in bold all your column names, and you had to set the types, the format type. You'd have to set whether something was a date or string. And if before you could fill out any row. And then later on, if you wanted to change any column, imagine you had to call up a developer and it would take them 2 weeks to change that column. They would, and then they would ring you back and say, yeah, we did a new release. We were able to change the column H from date to number. And you say, thanks very much. Just imagine what working with a spreadsheet would be like if those were the constraints. It would be, I don't think spreadsheets would be as popular as they are today.
No, really not. And I think the main point there for me is, and I've built a couple of companies before, is that it's actually a lot harder to change those than you think. Like you say, the 2 weeks, especially as the product grows more complex. And to go back to the definition of the relational database, at least with my understanding, is the relational database is basically a set of those tables. It's a bunch of those tables that refer to each other, such that the project column in my task list, my task spreadsheet, refers to a project table because the projects have different columns. And since in a classical kind of relational database setup, you have all these tables, and if you change something somewhere, it will actually, necessitate the change across all the tables that are referred to or refer to it. Would you guys is that a good visualization of it? Do you think a relational database? I don't want to get stuck with definitions, but I think maybe it's worth understanding because I think it provides context and kind of a visual cue to relate to all the insights you have behind XTDB.
Yeah, I do think so. I think I would like to say tables are pretty good, but it's the having to. I mean, they naturally, it's good to sometimes categorize knowledge, put them into tables. Where the problem lies is having to upfront decide all the column names and all the columns that a table represents. We call those aggregated types. You have to decide. Aggregate comes from the Latin aggregare, to travel together. So you have to decide which data fields are going to travel together for the life cycle of your database, which may be years and years and years. But the point of traveling together means sometimes, us three might get on a train and we travel to Stockholm, and then we leave Stockholm and Rasmus goes off onto a bus to go, to go home, and I go and visit a museum. We travel together for periods of our time, and then we diverge. And so deciding the things that are going to travel together for all time is quite a brutal constraint when you're doing information engineering. So yes, and I was also going to mention it would be every time the developer changes that column H, they also have to change column H in every other spreadsheet that you've made in the last 10 years. And that's why it takes more than 2 weeks, because they have to orchestrate this huge data migration too. So I think this what we are trapped in is this too rigid notion of information design, where it doesn't allow us to make mistakes and change our mind, and that is the real straitjacket, and that's why our information systems, I think, are very poor.
Yeah, and just to cut out that, because sorry, Martin, because I think you miss one thing that is where we are most passionate about XTDB at Multiply, and because you basically mentioned the flexible document nature of it, which means that it can function as a relational database, but it can evolve, right? So that was kind of the first thing. But we also XTDB is also a graph database in the link. So I just want to ask you, and this I'm really curious, the way we use XTDB, at least, I'm not sure if it's default or not, is that all links are bidirectional. And if you look at the web today, all links are unidirectional. You link from somewhere to somewhere else, but that link doesn't turn up on the website you link to, for good and bad, of course. What was that? Was it always like that, like with unidirectional links? And would you say that's a fair way to sort of describe the last kind of point about XTDB?
Yeah, I mean, there's a that huge debate about this in knowledge management circles. There's a good book by Tim Berners-Lee, who was one of the the author of the World Wide Web. It's called Weaving the Web, and he talks about this decision he made to make links unidirectional, and it has to do partly with having a very distributed web. It's very hard in what we call an open system to do bidirectionality, and there was sort of competing webs around. One was by Ted Nelson and Xanadu, which had the bidirectionality part of it. So bidirectionality is very hard to achieve in an open environment, but so that's why. But it has benefits. So that's why bidirectionality is possible to do in a closed database where all of your data is in a single place. If you try to scale it up to the globe, then it's much harder to do because you have lots of performance issues and constraints. So in order to unleash the web, it was important to relax one of those constraints and allow links to be one way.
But you're saying that in the ideal world, the web would be the bidirectional as well, with all links also being backlinks.
Well,
Backlinks.
it's a very useful property to be able to see backlinks. Yeah, and there has been attempts to do this through the backlink detection
Yeah,
but often you'll see those are in single websites
and it was a big part of the blogosphere, which is like when 15 years ago, when blogs grew into a big network of collaboration, that a standard appeared to automate
yeah.
backlinking. Yeah.
Yeah, and it was something that was retrofitted on later on because it definitely has value.
Yeah,
But
that's
it's
yeah, awesome. So and XTDB is a graph database. If you want to talk about what that is.
well, I think you can if you define a graph database as being a really a network between nodes, which we call entities and edges. So a graph is really just this kind of collection of relationships. In fact, you can build a graph just by having point-to-point relationships. You can a spider web. You can just draw a spider web just by drawing lines, right? Drawing points. So those relationships are all information carrying, and they're kind of that, but they are the every individual node in that graph is free to form whatever relationships it likes. So it is not constrained to the table that it's in, or it can only do foreign keys to another category of data. It's really very free form, and it allows you to. It's particularly good for modeling things that are very graph-like, and I think most data is graph-like. It's just you discover relationships all the time between things that you didn't know up front. So graphs are very flexible for that reason, but they are when there is some limitations, and that there is the style that we use in XTDB is called the property graph. So we have documents, which are a document. I should just define as being a set of named values. So,
Like
my name is
identities.
Malcolm.
Yeah, yeah.
Yeah, and some of those values might be, my friend is Martin, and so that is a relationship with somebody called Martin. Not all Martins, but a particular Martin. So that is so. We say that every value can optionally just be the identity of some other document in the database, and that gives you, I suppose, it's true to say yes, you can build graph-like information models on this. You can also decide that all your documents you're going to put in are going to obey a certain constraint or a certain schema but that's something that a user can decide. So it does allow you to have, I'd like to say, the best of both worlds. It does allow you to flex depending on your information model, whether it's more structured or less structured. And sometimes your information model is a little bit of both, and that's the problem. So you need a database underneath that is going to be as flexible as your app needs to be.
Yeah, it's interesting. Like, because if the way I sometimes pitch multiplier to someone who want to understand it deeply is that it's three things, and they actually tie very nicely into, of course, XTDB and of course Clojure as well. And then the third thing I think can lead us on to our next topic. But the first two I pitch when I explain it deeply is that it's fully flexible. Like we built a flexible, actually MVC model view controller, so enabled by XTDB, because we can basically define, different. What was the word you used? Just the document has a not a type, but a certain structure,
Property
a
graph.
property. Yeah. Okay. So we define these properties, and they can be like the columns in a spreadsheet on a data level, on the data model level in the MVC framework. On the view level, it can be, this is going to be a list, or this is going to be a table, or this is going to be a Kanban board. And then on the top level, it's like, what are the actions enabling users to actually put in, for simplicity, let's imagine buttons. And this button does a certain thing, and it has, access to all the different commands in Multiply. So you can say this button creates an article, for example. And then the second thing is the global graph nature of Multiply, which means that anything on Multiply is linkable with bidirectionality. So those are just relating concretely, for those who listened to the podcast before, to what we're building at Multiply and why we've chosen XTDB to do it. And the third thing I pitch, which I think I really want to hear your view on Martin, is that because we have a flexible semantic data model, semantic meaning that everything has a clearly defined and easily understandable meaning. This is the due date of a task. The due date means something. It's semantic. Because we have that, and because we have, that means purpose. So, for example, this is the introduction semantically to an article. And then we have this graph, which means that it provides context. So this article is created from the transcript of this podcast, so it links back to the podcast transcript. And then it has the introduction. That article is the first thing. That means that we both have purpose and context automatically available, and actually self-organized, which allows the foundation for autonomy when we come to AI, which is, I think, why people listen to this podcast, and we should get into some AI. So that's our kind of high level thinking on why what we're building is quite unique. And the reason we've gone into this before, but just to sort of give you a step into it, Malcolm, is that because we have automatic purpose and context for the AI expressed in a way it can understand, this is the introduction to an article that is written based on the linked transcript from the podcast Co-Creating with AI. Then the AI can understand what you want to do without you telling it, which enables us to build all these apps in our app store, but also allows users to create it themselves. And soon our apps will move on to have more and more autonomy, and we'll probably call them agents. So just with that kind of, I don't know, you take the frame you want, but just that's our frame. What do you think about XTDB and the co-creative internet now in the age of AI? Which you can, of course, take a lot of different lenses to, and I can suggest a few. But just to hear your general thoughts, I guess you've been thinking a lot about AI with XTDB as well lately.
Yeah, I think so. Yeah, a few things there that stick out. I think context is so undervalued. If you were to, take any book and just open it up and see a paragraph, you could argue, as I do, that even paragraphs in books, it would be ideal if there was an unique global identity for everything. So everything, even sentences and paragraphs in paperback books should be addressable, right? You should be, and that was, I think that was a property of the web that was really kind of interesting with respect to other forms of information creation, like word processing and, let's say Microsoft Word, where you write a big document, you save it as some file name, and the identity of that file name is sort of mydoc underscore v1 underscore final doc, and it's sitting on some SharePoint somewhere. It's just a very woolly identifier, and it probably wouldn't survive. The thing that the web allowed you to do is to put named anchors any way you liked in your document. That A tag that you can say href, you can also say name, and that then allows you to create a bookmark which is a globally addressable bookmark. So identification is incredibly important. Identify every sort of scrap of information. That allows an AI to go right at to be able to address that information uniquely, right, and not get confused as that it's actually another piece of information. But another thing that actually you need is context. If you opened up a book and you looked at a paragraph and you started reading it, and Mary said to Philip, "I don't love you anymore." Right? Who's Mary? Who's Philip? What's the context? What's the period? It doesn't. It tells you something, right? But it actually gives you more questions. And the only way you can answer those questions is through capturing context. Now, the context is there because you're sitting there with the book, with a paragraph. You can start flicking through the chapters. You could read the introduction. That's what an AI can do if you give it context. But if you don't give it context, if you have just addressability without context, then you lose that. I think I see this problem quite often in relational databases where you have column names. I was managing a very large risk aggregation distribution system in a bank, and we had database tables which would have columns that said CCY. I can tell you that means currency, but I can't tell you what the context is. You'd have columns that called X and Y, because in risk it's full of data points. X could be a tenor point in a yield curve, or it could be in some context a strike price, or so you have this kind of complete. You have data that is devoid of context, is meaningless, right? And that doesn't help an AI. AI thrives on being able to recreate meaning from context. And so I think these are absolutely foundational pillars that you have to have to unleash AI. And I think you're absolutely right on the money with identifying, identity, addressability, and context as being the key building blocks. It's not satisfactory. There are probably other things that you need, but these are absolutely key building blocks that you can't build an effective system without.
Yeah, thanks, Malcolm.
And we are also moving towards a paradigm where we're right where we are right now. The AI is operating within the structure the user has created, and but we are moving into the paradigm of the AI co-creating the structure as well as the content, and that's very exciting, and the because of the foundation of the philosophy behind multiply is sort of a content schema equality, that the the changing the schema should be as easy and accessible in the user experience as changing the content. Like changing the data and the schema should be on an equal level. And right now, we've made a thorough effort to make that equal for the user, and the next step is to do that for the AI as well, to make that equal, to change it, make it equally easily for the AI to change the content and the schema.
Yeah, I've learned a lot through actually just having Rasmus onboarded me as a kind of early adopter to Multiply. So I've had a few, had some fun with it and had some time to get more acquainted with the tool. And I've learned quite a lot from it. And I've one of the things I've been talking about for a long time is the need for developers, because I'm a software developer. So from my point of view, I'm saying that it's very important for developers to create systems that users can evolve and adapt without having to bring in the developers. And I think there are so many systems where developers are so ingrained into the change process that users are second class. If they want the column changed, they have to ring up the developer. It's been good for developers historically because we've ended up having good jobs, and we've been paid a lot because it's such an essential part of the process. But actually, I think there's a real failing of the software development industry for humans to be so ingrained into the process that it's become a very labor intensive process, and with very little, I would say, automation. We call it call these systems agile, and in fact these agile systems are, the agility comes from the fact that there are developers available, humans who can make changes quickly, right? That it doesn't mean that the system itself is agile. Often the system itself only supports today's current requirements and not tomorrow's current requirements. And sometimes that really doesn't mean tomorrow. Next year it means tomorrow. So I feel that we've got to move away from the pyramid building with lots of lots of human laborers
Mm.
approach to building software, to one where we liberate users to make most of the changes themselves. And my kind of classic example is the spreadsheet. When people use spreadsheets, they're not ringing up Microsoft Excel developers all the time asking them to change the spreadsheet. When people there were applications just before the web. Actually, we used uh, an application system called Lotus Notes, which some of your listeners might identify with an very poor email system that we had in the early days. And Lotus Notes was a system where developers could create documents and create applications without having they sort of became power users, and you could argue they became developers eventually, but there was this ease of being able to go from an idea to actually a really department level application. So I've seen it done, so I know it's possible, but I think we've gone far too far the kind of route of creating brittle applications that require constant attention by
Mm.
teams of developers. And we celebrate that as being, oh, we're responsive to change, and that's a good thing. We put good labels onto that, but actually I'm very negative about where we've ended up with agile. So what I see in Multiply is a kind of going back to the tradition of Lotus Notes, of allowing users to make changes. But what I didn't realize, right, and what I've kind of came a bit late to the party, is that by user we can also mean AI, right? So
Yes.
there's been a lot of activity of making AI be the developer, right? Like Copilot in GitHub is a utility where the developer can the AI can write the code for the developer. I don't think that that is going to that just perpetuates this constant like two worlds of the
Mm.
users and the developers. That actually just continues the misery of users, right? It
Yeah.
just means that I'm not sure whether perhaps it means that the 2 week wait can go down to 2 days, but it doesn't fundamentally address the problem. What fundamentally addresses the problem is building software, as you guys are doing, which liberates users to basically build their own structures and
Mm.
applications and evolve the product. And then you can invite an AI to the party, and the AI can have all of the prompts and the context that the users have, and so they can just join in. And I think that's a much more natural fit for AI to come in at the user level than in at the developer level.
Yeah, I really agree. I think that's a really, really, really nice point, Malcolm, and happy you're enjoying the product as well. Um, so just like, I think it's interesting, just like relating back to maybe to sort of start, I guess, summing this up to the kind of co-creative internet, which was our idea for, this podcast and what to talk about, is I think it's really like, if you look at it, like just relating back to what you said, the limitation is if you need to be a developer, if you need to have a special skill set in order to be a co-creator, right? We discussed that a lot. And AI is so interesting because it has the power to make things so much simpler for anyone to be a co-creator of the product they're using, of their software, etc. And I think that's really like also relating back to what Martin said, like that's what we're actually just doing it ourselves now together with the select number of like app creators. But since we're building this AI natively, the AI can actually create the structure inside Multiply, which means that I don't have to be a power user in order to utilize the flexibility we built, which, is still not something that everyone would do. But with an AI, with a natural language interface, which is like maybe the most beautiful thing about AI, is that it can understand just a normal person speaking or writing, and thereby allowing them to be a co-creator of the product they're using. So I really think like that's at least a fundamental reason why the co-creative internet has not maybe been possible before AI. Like just thinking back to 20, 30 years ago and Lotus Notes, etc. Like I've heard really good things about the people who did use it, from the people who did use it. But it was still like the journey of, as you said, maybe going from not being a developer to being a developer. Whereas, so that's still like a steep learn. Actually, maybe they did it well, but like a learning curve to go to being one of those special people, one of the magicians of the technology age, whereas AI maybe just means that I don't have to go up and become a developer. I can stay who I am and where I am with my skill set, but still be a co-creator because the AI can make it so much simpler. And that's not even, of course, taking into account kind of the collaboration aspect of it, which I think we've been meaning to dive into for a while, like how AI can not only enable productivity but collaboration. But I think maybe that will be another episode. But that was just what came up to me from hearing both of you speak.
Yeah, that's nice. I think I can't remember Lotus Notes too well. It was a long time ago, but I think you could become a power user simply by using the tool, just by spending more time with the tool. And I think that's a good test. If in order to become a power user, you have to go on a course or read a book or then that takes a degree of effort. So I think there's two tests. The first is there a is just by using, like you're playing a game. People who play a game, they get better at the game and they can defeat the final level boss, and they can do all of that and get all of the skills that they need by playing the game. They don't have to go off and read a book or watch YouTube videos. I'm sure that's a bad example because most people do watch YouTube videos to work out how to play, but in theory you can just play the game. And I think that it's just by spending time. I think where AI can also help is by when we were learning how to be power users, we're often doing it on our own and making mistakes. And I think having somebody sitting next to you saying, try this, or that's right, or working at your level, having an own personal tutor that understands. I think education is going to be transformed by AI because it takes the individual from where they are. You're not treating a class of students and you're trying to, one teacher with 30 students is assuming that every student is at the same level and they're all ready to go up to the next step. And we know that that's not true. So I think where AI is transformative is that it can be personal and it can be forgiving and understanding that you know where you are and trying to take you forward. And I think that can be a useful thing for training people how to use software and get more out of software. And that might be the next innovation.
Excellent. Thank you so much, Malcolm. This
Thank
has
you.
been an excellent conversation for me. I've learned a lot, and especially what I take away from this is how everything we do exists in the context from that what came before. That how much is informed consciously or subconsciously about what we've experienced in technology of the past.
Yeah, I
Yeah,
agree.
thanks. Thank you very much. I've really enjoyed the conversation. It's been great.
Yeah, thank you, Malcolm. Thanks a lot for coming on and telling your story and what you're doing now.
Thank you very much.
And thank you, the listener, as well, for being with us all the way to the end of the episode. This has been an episode of Co-Creating with AI, and I'm looking forward to seeing what other guests we are bringing in the future. If you have ideas, let us know at Martin or Rasmus at multiply.co, and tune in for the next episode to see what we're up to then.